Hello everyone, so welcome back. In this video I'm going to solve more problems involving double angle identities and integration. So let me show you how to integrate cosine to the power 4. And after this example I'll do an interesting difficult one, okay? Alright, so when do we use double angle identities? When we only have an even power in the trigonometric function. So we have 4, that's even. Good. Only even, okay? You don't see any odd power trigonometric functions in this integral. So we can use double angle identities. So let's convert this cosine 4. Now, cosine square, as we know from the double angle identities, it's 1 plus cosine 2x over 2. The double angle identity is for cosine square, but we have cosine 4. Well, let's just square the left hand side. So then we have to square the right hand side too. So cosine to the 4 is actually 1 plus cosine 2x over 2 times 1 plus cosine 2x over 2. Right? Okay, so now what we can do here is, well, let's FOIL this. So if you FOIL this, well, 1 plus 1 is 2 times 2 is 4, that's denominator. Okay, I like to do this problem slowly. 1 plus cosine 2x, 1 plus cosine 2x. Okay, and then let's multiply out. 1 times 1 is 1. 1 times cosine 2x is cosine 2x. Cosine 2x times 1 is cosine 2x. I am foiling it, okay. Cosine 2x times cosine 2x is cosine square 2x over 4. Alright, so let's see what we get. 1 plus 2 times cosine 2x, because there are 2 cosine 2x, plus cosine square 2x over 4, right? Okay, so now what we can do is, well, if you look at the result, so let's write it again. If you look at the result, we still have an even power. I mean, we still have a power greater than 1. So we can't stop here, right? Remember, the purpose of double angle identity is to use it again and again, over and over again and again, until you get a cosine of power 1. But here we have cosine square, so we again have to use double angle identity. But let's simplify this first. Let's divide each term in the numerator by 4. So it's 1 over 4. 2 cosine 2x over 4 is cosine 2x over 2. This is cosine square 2x over 4. Alright, so now we want to get rid of this term, but we know cosine square x is, okay, let's use the double angle identity again. Cosine square x is 1 plus cosine 2x over 2. This is where most of you do a mistake. I explained that in the last video too. Cosine square x is 1 plus cosine 2x over 2, but we have here cosine square 2x. So if we have 2x here, what will you have here? Cosine 4x, double of what you have here. So be careful, okay, when you use double angle identity. Here cosine 2x over 2 plus cosine square 2x is 1 plus cosine 4x over 2 divide by 4. Okay, so be very careful. Now let's simplify. 1 over 4 plus cosine 2x over 2. Here 1 plus cosine 4x over 8, right? 4 times 2, 8. This is cosine to the power 4x using double angle identities twice. Now if you look at the result, it's long, but cosine, all the cosine functions have only power 1. All the trigonometric functions have only power 1. So we achieved our purpose, right? So then now let's do the integration. So let's integrate with respect to x. What do we get? If we integrate 1 over 4, we get x over 4. If we integrate cosine 2x, we get sine 2x over another 2. That new 2 and these 2 will produce 4. Here, let's divide each term here by 8, right? Each term in the numerator. So that's 1 over 8 plus cosine 4x over 8. Now let's integrate. If you integrate 1 over 8, you get x over 8. If you integrate cosine 4x, you get sine 4x. Divide by 4. That 4 and 8 multiply. 8 times 4 is 32 plus c. Now this is what you get if you integrate cosine to the power 4. Okay. See how do we use? See how do we do trigonometric integration? When you have only even powers, you use double angle identities over and over again until you get a function like this. function with only trigonometric powers of 1, and then you do the integration at the final step. Okay, actually we do integration at the final step, right? Okay, all right, so let me do an interesting example. Okay, so this is x cosine square x. All right, now this is little bit tricky, more than little tricky. Okay, so now we can see there's only even power, right, of the trigonometric function. Don't focus on x. So let's use double angle identities. Okay, but before that I have a suggestion for you. Okay, it's sometimes good to do mistakes and learn from your mistake. I highly encourage you to use integration by parts here. Use LIAT rule and try to think how to use integration by parts. Okay, oh well, we can use integration by parts here. Yes, we can use integration by parts here. Well, I think it's my mistake, I'm sorry about that, but yes, you can use integration by parts. It's just in my head I had a different strategy to solve this problem, but let's use integration by parts. Okay, I'm sorry about that. Well, that's a very embarrassing moment, but I don't want to remake this video because this problem is so long. So okay, let's go ahead with my mistake. Well, okay, let's say I accepted my own challenge and I'm going to do integration by parts here. Because why not? Why do we use integration by parts here? Because this is a product of two types of functions, right? We have x algebraic function and we have a trigonometric function. Okay, by the way, okay, let me tell you what I had in my mind. Okay, that's also good. I was thinking to use double angle identity for just this term and then later multiply by x and do the integration. You can do that as well. Okay, but anyway you will have to do integration by parts. But let's start from integration by parts here. Well, we have an algebraic function and we have a trigonometric function. Why not, right? So our choice for u is x and choice for dv is everything else, cosine square x dx. Alright, so you know u, so you want to find du over dx. This is a difficult example. Okay, this is not something that you would see for the very first time that you learn trigonometric integration. Okay, so don't be afraid, just watch and learn how to do. So okay, so we know du, we know u, we need only one more thing, which is, yes, v. How do we get v? We have to integrate cosine square. Okay, how do we integrate cosine square? Now think about that. That's another small integration problem inside the main integration problem. So to find v, we have to integrate cosine square. How do we integrate cosine square? We use double angle identities because this is a function, trigonometric function with only even powers. So cosine square is 1 plus cosine 2x over 2. Okay, this can be written as 1/2 plus cosine 2x over 2 dx. So this is, if you integrate x over 2, cosine, if you integrate sine 2x and you divide by 2, that 2 and this 2 will give you 4. So this is v. Complicated, right? So it's a complicated v. Okay, all right, now what we can do is we can use the formula. So uv minus integral v du. All right, so u is, what is u? X. V is this lone term, x over 2 plus sine 2x over 4. V is x over 2 sine plus sine 2x over 4. Du is dx. Okay, now let's finish the integration. So this is x over 2 plus sine 2x over 4. Here if you do the integration, here it's easy, we can integrate these two separately. If you integrate x over 2, you will get negative x square over another 2 comes down. With this 2 it's 4, right? Integral of x is x square over 2. Now if you integrate sine, you get negative. So let's have a bracket here. Let's have like a bracket. So if you integrate sine, you get negative cosine 2x over 2. With that 2 and this 4, it's 8. Okay, plus c. All right, so this is x over 2. I could have simplified this, but I'm a little bit lazy. You can do that. X square over 4 plus negative plus cosine 2x over 8 plus c. Okay, so this is not what I expected. Okay, but That's hilarious, right? I was just challenging you, and then it's good that I realized, well, I can do this problem by integration by parts. Okay, so this is one way to solve the problem. Now I want you to understand, here's the takeaway. I want you to understand this problem is very different from x integrating x cosine x. Here the integration by parts is easy. Here also you use integration by parts because it's a product of two types of functions. Yes, but integrating cosine square is not obvious. Okay, it's a trigonometric function with a power, with an even power, with an only even power. Then we have to use double angle identities. Okay, all right, let me give you a new challenge. Okay, same problem. Try to, okay, here's the second way you can do this problem. Try to use the double angle identity here first without using integration by parts. That means cosine square will be like 1 plus cosine 2x over 2. You can do this also. Then you can distribute by this x and then try to integrate. Okay, let me give you a hint. So if we distribute, this is x plus x cosine 2x, that over 2 we can take it out as half. Now see, now try to integrate this. Okay, but be careful, here you have to still use integration by parts, but this integration by parts is easier than using integration by parts right away here, because here you have a cosine square, then you have to use double angle identity, but here you don't use any double angle identity or any identity at all. You can just use normal integration by parts. Okay, so two ways to solve these problems. I personally prefer this method, is I think easy, starting from integration by parts. Okay, so that's done. Now what are we going to do in the next video? Next video I'm gonna show you how to integrate trigonometric functions when you have at least one odd power. Because remember, we use double angle identities in problems where you have only even powers for trigonometric functions. Okay, so I'll catch you there. Thank you very much for watching this video. Bye bye.